Hi, geometry kids. This is Mrs. Raposa, and I'm just going to go over a little the homework that on the geometry review 7.4 to 7.6. First of all, for the first 5 problems, there's no need to use sine, cosine, and tangent because these are all 45, 45, 90 triangles or 30, 60, 90 triangles. So you just use the ratios. Save yourself a lot of work here. So 45, 45, 90 triangles, you know the legs are the same length. So this must be 25, the same length as this one. For number 2, you were given the length of the hypotenuse on a 30, 60, 90 triangle. Whenever you have a 30, 60, 90 triangle, the length I want to know first is the short leg because everything depends on that. But this one we have to work backwards. So 2a is 6, so go backwards to the short leg. 6 divided by 2 is going to give us 3 because this is double this length. Okay, and then to get the length of the long leg, you just take the length of the short leg and multiply it by root 3, which is about 1.7. So this is about 1.7 times bigger than this, but we don't want a decimal approximation. We want the exact value. For number 3, again, 45, 45, 90 triangle. This time you were given the hypotenuse, a root 2. So a root 2 is 8 root 2. That means that the leg length is 8. Okay, just go backwards. For number 4, you were given the length of the long leg on a 30, 60, 90 triangle. So you were given that a root 3 is 11 root 3. So 11 root 3, that means that the short leg must be a, 11, which they're calling b in this case. And then to get the length of the hypotenuse from the short leg, just double the length of the short leg, and you get the hypotenuse is 22. So for number 5, again, we were given a 30, 60, 90 triangle, but this was a little challenging because the length of the long leg is not in a number times root 3. It was a whole number 12. So across from the 60-degree angle is 12. So that's 12 is equal to our a root 3. Divide each side by root 3, and you'll get 12 divided by root 3. Rationalize the denominator, you'll get 12 root 3 over the whole number 3. But 12 root 3 over 3 is 4 root 3 because 12 thirds is 4. It's kind of like 12x over 3 is just 4x, okay? Number 6, I think it's pretty self-explanatory, but you have to be aware of which angle measure, which angle is your reference angle. If you're that's why I didn't mark them as like opposite, adjacent, and hypotenuse, because it depends on which angle you're looking at. If you're looking at angle S, then this is opposite. Right here, this length TA. But if you're looking in reference to angle R, then this is adjacent. So it depends on which angle you're looking at. So I didn't mark it up here. That's why the sine of angle S and the cosine of angle R are the same thing, because in reference to angle S, sine is opposite over hypotenuse, 21 over 29. In reference to angle R, the cosine will be adjacent over hypotenuse, which is still 21 over 29. And this is self-explanatory. Opposite over adjacent in reference to angle S. Opposite over adjacent. Okay. These are the tougher ones. For part A, I wasn't sure if that was supposed to be a 50 or if it was a 60 that got cut off, so I solved it with both numbers, and so I'll accept either one of these answers. But in reference to this 18-degree angle, you know the opposite leg length, and you want to find the hypotenuse. So I need a ratio that relates opposite to hypotenuse, and that is the sine ratio. So the sine of 18 degrees is 50 over x. Multiply each side by x to undo the division by x, and you'll end up with this. Divide each side by the sine of 18 degrees, because the sine of 18 degrees is just some decimal. So this length of the hypotenuse is just going to be 50 divided by whatever the sine of 18 degrees is. You'll get about 161.8 meters. If you use 60 and thought that was a 60, then you'll get this answer. For part B, in reference to this 40-degree angle you were given, this is the opposite leg, and this is the adjacent leg. So I need a ratio that relates opposite to adjacent, and that's the tangent ratio. So the tangent of 40 degrees will be 900 over x, opposite over adjacent. Again, multiply each side by x, or if you want to use a shortcut that I always like to use, if the variable you're solving for is in the denominator, only if it's in the denominator, then just swap the x with the tangent of 40 degrees, have them change places. So we'll have x equals 900 over tangent of 40, and you get about 1,072.6 feet. For the challenge problem, for For this particular problem, you had to determine which line to draw and then find out what B and H were in base times height. Area equals 1/2 base times height is the area of a triangle. So in this case, the base is given, it's 9 centimeters. You had to draw in the height of the triangle. So the height of this triangle makes a right triangle on the left side and another right triangle on the right side. We're going to concentrate on the one on the left because that's the one that I have the angle measure for. So in reference to the 70-degree angle, I kind of drew it over again over here. I want to find the opposite leg length, and I have the hypotenuse length on this right triangle. So opposite over hypotenuse means I'm going to have to use the sine ratio. So the sine of 70 degrees will be opposite leg over hypotenuse, which is really the height of the triangle over this length of the side of the triangle. So sine of 70 equals x over 6. This represents the height of the triangle. Multiply each side by 6. And you'll have 6 times the sine of 70 degrees, which is about 5.638 centimeters. So the height of this triangle is 5.638 centimeters. Now let's use this formula for area. Area is 1/2 base times height. The base is 9 centimeters. The height is 5.638. Just multiply those all together and you get 25.37 or about 25.4 square centimeters because area is measured in square units. For this particular problem, number 2, again a challenge problem, we have a 30, 60, 90 triangle stuck to a 45, 45, 90 triangle. And the hypotenuse of each triangle is this length. So I'm going to kind of break it down a little bit. Let me go to the document that's behind it. Let's start with the 30, 60, 90 triangle that's on top. That's right here. I covered up, what I did is just covered up the bottom, so you can just concentrate on that. You were given the length of the long leg across from the 60-degree angle. So this is our A root 3. So 9 root 3 is A root 3, which means that A, the length of the short leg, is 9. To find the length of the hypotenuse, that's just going to be twice A, or twice 9, 18. So the length of this hypotenuse on the 30, 60, 90 triangle is the same as the length of the hypotenuse on the 45, 45, 90 triangle that's stuck to it. You were given the length of the hypotenuse. So this is acting like our A root 2. To go from the leg to the hypotenuse, we would have to multiply this length by root 2. So to go backwards, we're going to divide by root 2. 18 divided by root 2, rationalize the denominator, you get 18 root 2 divided by whole number 2. But again, this is like 18x over 2, which is just 9x. So it's 18 root 2 over 2 is 9 root 2 is the length of the leg. If you still have questions, you can always contact your teacher. Remember, you can go to Google Meets or you can always email someone to ask for help. Hope that helped.